I made a general high-efficiency Python guide for beginners, and I also read all my comments. While going through them, I saw that a lot of people wanted me to review a more advanced project and generally show off how I go about it and my thought process. So that's what we're going to be doing today. Speaking of the comments, I do not sound like Doofenshmirtz, and when it comes to Victor, I'm only doing this once. The final, glorious evolution. So for me to start explaining what sort of script I want to make, we kind of have to understand what I'm making the script for. All of this is based around the game Osu. Doesn't matter if you play it, it's still gonna be cool. Long story short, in Osu, you have a bunch of circles, you need to click on them, and there are some difficulty increasing mods. Some of them change the way that you see the circles, so they make them very hard to see, or just outright make them invisible. So then I thought to myself, okay, there's this difficulty increasing mod called Flashlight, which basically only lets you see in a small area around your cursor and you can't see the entire screen. And then I thought, wait, wouldn't there be a way for me to render the circles on top of the screen through an external overlay? And then I got cooking. So here's the plan. I want to play with a visibility reduction mod and still see every circle as if there were no mod. In order to do this, I need the circle positions, the circle timings to know when the map starts, and then just render all of those on top of the overlay that I create. Now the question is, how do we get the circles? In this game, people pick a song and then they start creating a map for it. A map is basically a combination of circles and sliders and stuff that sync to the rhythm of the song, because this is a rhythm game after all. What we're interested in is actually the circles inside of the map. We don't really care about the song. But how do we extract the circles from inside of the map? Well, I found out that the map files for Osu are actually text files that you can just open and read the text of. And when scrolling through this, I found something interesting. Right here, we have the hit objects. We have the X, Y, and timing offset for every single circle. So this means that I don't have to do any crazy pixel scanning stuff. I can just get the exact circle positions and timings directly from the bitmap file. Okay, cool. But there comes our first hurdle. How do we get that file? I mean, this script is supposed to be external. We're not going to have memory access. We're not going to be able to read the map that easily. So there's a few methods to do this externally, and I tried all of them. The first one I ever tried was scanning this area of the screen and then using OCR, using image recognition to try to turn that image into text. This wasn't working out very well for me. And also it had several different fonts and languages, and it just got quite complicated to the point where there was no reason to go down that route, and it was just not the best way to do it. The second option was the first one I incorporated when I released this. I would make my script click here, press 1, it would have the browser open, it would press Ctrl L to focus on the URL section, Ctrl C to copy it into my clipboard. Then I would string strip the unnecessary sections of the string, and I would only have the map ID. I would then take the map ID, put it in the Osu API where I can download stuff from a URL, and the only thing that I need to input is the map ID, and then I would get the map. I would parse the map, and then I would continue my script. But here's the thing. Apparently, when you load up an Osu map, your Osu window title changes from just Osu to Osu and then the name of the map itself, so that makes it so much easier. So notice how programming is actually more about solving problems than writing the code itself. This was one of my biggest issues when creating this, and the solution was actually to take a step back and to analyze the whole system to see the best way for me to do something, and only then I would approach it by automating that task with the code itself. So that's why I'm trying to teach you how to think rather than focusing on the code itself too much. Speaking of which, let's hop straight into the code. I'm gonna make a loop that constantly looks for what window I'm in, and then if the title is Osu, then it's gonna print out the name. We can use this as a proof of concept. So now when I have Osu focused, it says Osu, but then when I start playing a map, it actually says Osu and then the map name as we expected. But what I actually wanted to do is to constantly scan for the name of the window until it sees that it's an Osu window and it also is long enough to have the map name in it, meaning that I started playing a map. So I'm gonna add this length position, and then instead of printing it out, I'm just gonna break the loop. So here's how it would actually work in my script. I'm gonna run the scanner. Now I clicked on Osu. It doesn't say anything, but the second I start the map, there we go, it gives me the map name and it breaks the loop. Then I'm gonna look through my songs folder with my map name to try to find the specific folder for the map. And then that's gonna have multiple difficulties. So I'm gonna split the map name from the difficulty, and then I'm gonna have another function that is gonna look inside of the map and match the correct difficulty. Then I'm gonna get the map data, and now we can go into the overlay with it. This is the overlay itself. I just made it with the Kinter. It's not very interesting, but what I wanted to talk about were the functions inside of it. Currently, the map data looks like this, but we need to somehow process it so that we can get the specific things that we need separated, such as the positions, the timings, and other important information. So first I'm going to split the map data into the different sections that it has, and then I'm going to look for the difficulty section where we're going to get a lot of important information. The two main values that we need are the circle size and the approach rate. The circle size determines how big the circle is going to be, and the approach rate shows how much time it takes from the moment that the circle appears on the screen to the moment where you have to press on it and until it disappears. So we're going to use that to figure out when to delete the circle from the screen. I then wrote some formulas to transform the circle size into actual pixels and to transform the AR into milliseconds so we can figure out the timing. Speaking of which, now let's look at the main parser. We need to look at this abomination and extract the XY coordinates and the timing offsets. Those are the first three elements on every row. This gets a lot more complex because there's also sliders and return sliders and spinners and all sorts of stuff. It's not just circles. So I had to write a bit more for the parser, but I won't go into detail. One thing that you should know is that I spent a moderate amount of time with trial and error trying to figure out how to convert OSU coordinates to 1080p coordinates, because much to my surprise, they are not the same. And when I tried to draw them in OSU coordinates, they were all completely messed up. So I had to remake all of that. It took quite a while to find the specific formula, but here you go, in case you need it. The parser then takes all of them and puts them in an array. And then later on, when I want to draw them on top of the screen, they're taken from the array and they're displayed one by one in chronological order, and they're removed at the proper offset. Now let's get into how the sequence actually starts, because this was another big challenge. So now we have the delays between the circles so that we can display them at the proper intervals. Without knowing when the map starts, we can't properly align the first circle starting so that we can have all of them in the proper sequence and they actually match the also sequence. For that, we would need the right millisecond in which the map starts. But that's actually very hard to get externally because the loading time is inconsistent, and the only way you could do it is with pixel scanning. Originally, I tried to scan this thing, but that was very bad. No, that doesn't work. A better alternative is to scan the area where the first circle will appear. First, you need the area to be black, which means that the map properly loaded. But even there, I needed to add some variance because sometimes it didn't fully turn black and then the script just didn't run. Once it did turn black, it would start scanning one specific pixel where the object will first appear, and then the frame that it sees it starts running the script and starts displaying everything, and that should maybe have like a 1 to 2 millisecond delay. So it should be fine. I don't even need to account for it. So here we have a map with no mods, the same map with hard rock, and then the same map with easy. As you can see, the mods actually impact the map quite a lot by changing the circle size and the position of them. So we need to account for that in our code. Getting the mods was actually a bit tricky since I'm not using internals. That means that I can't just pull them from memory and see what mods are active. I need to figure out what mods the user activates before playing every map based on hotkeys and external factors. And that's exactly what I did. Pixel scanning would be very machine specific, so I just decided to use hotkeys. So just track the hotkeys and assign them the corresponding mod. It's not that hard, right? Well, kind of, but here's the problem. A user can just press the same mod multiple times, and also there's mods that disable each other, so that makes it a bit harder. I have a string, and every time I press a hotkey, the corresponding mod will be added to the string. This will be sent into the overlay where it will be parsed. So basically, hard rock and easy disable each other. If I had easy enabled and then I pressed hard rock, my script will check through that entire thing to see if hard rock was pressed after easy and then disable it. It will also check if I press them an even or uneven amount of times to know if I disabled them myself. Basically what this means is that I can just spam as many buttons as I want and it will always get the right mod. And here's a quick demonstration of me doing that and making my script print them out. There it is. Now I can make it so that if I play hard rock, I can invert the circles on the x-axis. I can change the approach rate and CS. I can change the timing if I'm playing DT. Basically making my script compatible with most mods. There's a bunch more functionality that I didn't go over, but that's not as important. Now let's see how the script actually plays out. And since it's also, and it's gonna have music in it, I need to make a cover for everything so that I don't get copyrighted. Like half of the views on my channel. So the green and red circles that you see are from my overlay, because normally in also with my skin they're all white. I have a few clips that showcase how it looks on my screen compared to how it looks in game, and I'm gonna put them on the screen right now. And now let's get into my gameplay from today. I have not played games in a long time. I don't want to hear anything about my gameplay. Yeah, no, I'm not doing this one. Yeah, so pretty cool script. I generally enjoyed it. The hardest part for all of this was making it so that I can actually restart the map and automatically detect new maps and make it properly stop when I press escape. That definitely didn't work the first time, and it took me the longest out of everything to make. But yeah, this is the outro, so yeah, that's about it. Thanks for watching. This took me a long time to edit, so I hope you liked it and maybe learned something from it.